Hi everyone, today I'm going to be talking about which method is best to use, the disc washer or shell method. This video really isn't going to go into much depth about how to use each method and what to use for your radii and your heights, but rather just which method is best to choose, because when I first learned these methods, that's what always confused me. So, I imagine that's what confuses others as well. So I thought I'd make a video on it. So jumping right into it, the washer method is best to use, especially when you have a region being revolved, but then you also have a inner region being revolved, but that region does not have any volume. So as we can see here, this shaded region is being revolved around the x-axis, but there's also going to be a cylindrical space between the region that's being revolved. So that's how you know to use washer method, or at least a hint that you might be using washer method. Okay, so the other indicator that you will be using washer method is that the function that you are given is written in terms of x, and your axis of revolution is also about the x-axis. So I always like to think of it as x goes with x, and then once I've established that I'm a function in terms of x and my axis of revolution is parallel or equal to the x-axis, that's when I know that the washer method is the safest and the best route to go with. And similarly, when you have a vertical axis of revolution, it's best to use washer method when you have your function written in terms of y, because just as x goes with x, you always want to pair up with y. So this function right here, y squared plus y over 5 plus 1, is bounded by 1 and 4. And again, we just want to integrate in terms of y because we have our vertical axis of revolution along the y-axis, and then this shaded region here is also being revolved around that axis, and the function is in terms of y. So that's how you know the washer method is best to use in that case. Okay, so next up is the disc method, and I'm not going to spend too much time on the disc method because really it's just a special case of the washer method. They are similar to each other in that they are both being revolved around and integrated in terms of the same variable. So again, x goes with x and y goes with y. But they are dissimilar to each other in that the washer method has a region that is being hollowed out of the larger region, but in the disc method, that does not occur at all. There's just a solid area being revolved around an axis to get a solid volume. So it doesn't really look like a washer, it looks like a disc. That's why they're called the disc and washer methods. So right here we have f of x square root sine x. So that's this shaded region right here, and I've drawn in the differential strip too. But anyways, so the function is being written in terms of x, but then we also have the axis of revolution being equal to y equals 0, the x-axis. So again, here since we have the function written in terms of x and the same variable of revolution, axis of revolution, we're going to be integrating in terms of x. So also in the vertical axis of revolution, we have the function written in terms of y, so we're going to integrate with respect to y. And I realize here that you can solve for x, solve in terms of x, I should say, to be able to utilize the shell method, which I'll get to in a minute, but I just made this function up for the purpose of the video and the method at hand. So I'm going to go over the shell method next. So the shell method is sort of the inverse of the disc and washer methods. So before, x went with x and y went with y when we were talking about the functions and the axis of revolutions. But now, for the shell method, we want the opposite. We want the function written in terms of y and the axis of revolution to be y equals 0, or the x-axis. So y goes with the x-axis. And similarly, we have the function written in terms of x, but we have the axis of revolution being vertical, the y-axis. So here it's going to be pretty hard to solve for x, so we want to keep the function in terms of y, and we have the axis of revolution along the x-axis. So this time we want to use shell method because the variables are opposite, and we always want to integrate with respect to the variable in which the function is written. So since we have e to the negative y squared, we want to integrate with respect to y. And now, just as we did in the horizontal axis of revolution and the vertical axis of revolution, we have a function 5x minus x squared. Then we want to integrate with respect to x, since that's what the function is written in terms of. And the indicator to use shell method is, again, that our function is written in terms of x, but our axis of revolution is the y-axis. So y went with x, so therefore we use shell method. Okay, so the main takeaway of this video is that the disk and washer methods always are paired up with the same variable. So if we have the function in terms of x and we have the axis of revolution about the x-axis, then we want to use disk or washer method, and the same thing goes for y. But if we have a shell method, if we have opposite variables, so the function is written in terms of one variable, but the axis of revolution is along another variable, then we want to use shell method.